Welcome back. I did eat a little food, so let's read some more. This old camcorder can record like half an hour, 2 gigabyte. It's very old records, so we're not in a big hurry. I buy some spare camcorders. So now I use it because my other camcorder did broke. But in 2 months I will have some more money. Now this camcorder can record half an hour, 2 gigabyte. A normal video 15 minutes is 4 gigabyte. This camcorder is 4 gigabyte 15 minutes. But this is not an English vlog video. I'm reading about computer processors. How to make computer processors, but I was supposed to and history about computers. I did not finish my mechanical calculators, but I have it on my list. But my read list is a little bit mess. But I have my own system. So I like to read about these 3 old transistors. They are not on this list. I need Zilog. But Grown-Junction, I forgot, should be Grown-Junction transistors. We need one word more. Now I need my pen. But I was supposed to make it in English, everything, but I do it in my language. Danish, maybe in the future. You got some AI translator on YouTube. Or maybe in the future you can watch YouTube video like German or French or Chinese or Italy or Spanish. Then it will translate. You can select translate to your own language, like my language, Danish or English. So now I'm going to read this. Yes, I need to go to my bed.
Grown-Junction transistor. This article needs additional citations for verification. Please help improve this article by adding citations to reliable sources. Unsourced material may be challenged and removed. Find sources. Grown-Junction transistor news times newspapers times books times scholar times Chster. February 2024. Learn how and when to remove this message. The Grown-Junction transistor was the first type of bipolar junction transistor made. It was invented by William Shockley at Bell Labs on the 23rd of June, 1948. Patent filed the 26th of June, 1948, 6 months after the first bipolar point contact transistor. The first germanium prototypes were made in 1949. Bell Labs announced Shockley's Grown-Junction transistor on the 4th of July, 1951. An NPN Grown-Junction transistor is made of a single crystal of semiconductor material which has two PN junctions grown into it. During the growth process, a seed crystal is slowly pulled from a bath of molten semiconductor, which then grows into a rod-shaped crystal, boule. The molten semiconductor is doped N-type at the start. At a predetermined moment in the growth process, a small pellet of a P-type dopant is added, almost immediately followed by a somewhat larger pellet of an N-type dopant. These dopants dissolve in the molten semiconductor, changing the type of semiconductor subsequently grown. The resulting crystal has a thin layer of P-type material sandwiched between sections of N-type material. This P-type layer may be as little as 1/1000th of an inch, 25 micrometers, thick. The crystal is sliced, leaving the thin P-type layer in the center of the slice, then cut into bars. Each bar is made into a transistor by soldering its N-type ends to supporting and conducting leads, then welding a very fine gold lead to the central P-type layer, and finally encasing in a hermetically sealed can. A similar process, using the opposite dopants, makes a PNP Grown-Junction transistor. The most difficult part of this process is welding the gold wire to the base layer, as the wire may have a larger diameter than the thickness of the base. To facilitate this operation, the gold wire is pointed or flattened until the end is thinner than the base layer. The tip of the gold wire is slid along the bar until electrical resistance measurement shows it is in contact with the base layer. At this time a pulse of current is applied, welding the wire in place. Unfortunately, sometimes the weld is too large or slightly off-center in the base layer. To avoid shorting the transistor, the gold wire is alloyed with a small amount of the same type dopant as used in the base. This causes the base layer to become slightly thicker at the point of the weld. Grown-junction transistors rarely operated at frequencies above the audio range, due to their relatively thick base layers. Growing thin base layers was very hard to control, and welding the wire to the base became harder the thinner it got. Higher frequency operation could be obtained by welding a second wire on the opposite side of the base, making a tetrode transistor, and using special biasing on this second base connection. See also, edit. 1 alloy junction transistor. References, edit.